And finally, let us look at the regioselectivity or orientation rule. So, we have a diene and we have a dienophile which are having substituents. So, how the product will be forming, because the addition can take place from both the electron withdrawing group and the alkyl group from the same side, or we can also rotate the molecule like this. The diene can have the electron withdrawing group at the bottom. So, this way also it can add to this one, that means the R and this electron withdrawing group will be present in the meta position similar to the aromatic system. So, we have two types of products possible, one in which the two substituents are ortho to each other, another one case the two substituents are meta to each other. So, we have two different types of products possible, but in most of the Diels-Alder reactions this is the only product that is formed. And similarly, if there is a substituent on the second carbon atom, when the electron withdrawing diene reacts with this particular dienophile reacts with this particular diene, we end up with a para substituted product, similar to a para substituted product, but not the meta substituted one. So, let us look at why or how this reaction actually proceeds. Let us look at the orthoselectivity. We have a electron donating group on the diene. So, this EDG actually can donate the electron towards the diene double bond, and due to that electron donation, this particular terminal carbon gets the negative charge. So, in other words, what we can say is this particular carbon becomes nucleophilic in nature. So, in other words, this becomes electron rich because of the electron donation from the methoxy group here. It can also be a methyl group that also can inductively donate electrons. So, in other words, whenever we have a electron donating substituents basically on this particular diene, then the terminal carbon actually gets the more nucleophilic nature or character. This is the diene. We have dienophile. There is a electron withdrawing group on the dienophile. So, when there is a electron withdrawing group on the dienophile, what happens? This pulls the electron towards itself, making this terminal carbon electrophilic in nature. In other words, there is a delta positive charge present on this particular carbon. So, the dienophile makes the terminal carbon electron deficient. The methoxy group on diene makes this terminal carbon nucleophilic. So, this actually helps in understanding how the reaction will actually proceed. Now, we have a negative charge on one of the terminal carbon, we have a positive charge on another terminal carbon. So, that means these two only can actually interact very effectively. In other words, this is the major requirement for this particular reaction to proceed. In other words, the electron withdrawing group on the diene and the electron donating group on electron withdrawing group on the dienophile and the electron donating group on the diene are ortho to each other. In other words, this is what is the product we will be getting in this particular reaction. If you go back to the other case, when there is a electron donating group which is present on the second carbon atom. So, in this particular case, the electron the lone pair of electrons from the substituent amino group is actually given to this particular diene double bond. So, we have a carbon terminal, one of the terminal carbon having negative charge. In other words, we have the delta negative charge on this particular terminal carbon, but no difference in this other terminal carbon. So, whenever we have a substituents on the second carbon, whichever is the carbon which is close to this substituent is the one which gets the negative charge. And in the case of diene, which is very similar to the terminal carbon, is actually going to be electrophilic in nature. So, this particular carbon is actually going to have the negative charge, or this is more nucleophilic in nature. We have a electrophilic part of this particular diene. So, these two can now react very effectively. In other words, we end up with a product where the substituent on the diene and the dienophile are basically placed in the para orientation. So, this is how the regioselectivity is controlled by this particular Diels-Alder reaction.